Hi, I'm Rich with insideHPC. We're here at SC12 in Salt Lake City, and we're here at the Cycle Computing booth. I'm here with the CEO, Jason Stowe. Jason, let's start at the beginning. Who is Cycle Computing, and who do you help?
So Cycle is the leading provider of software to build utility supercomputers. We help people take workloads, run them on internal infrastructure, whether it's multiple clusters, VMware environments, or internal clouds, and then be able to take advantage of massive capacity on cloud providers like Amazon Web Services, where we can create 50,000 core clusters in under an hour, run them for a couple of hours, and then turn them off, and you only pay for what you use.
So you guys can provision a 50,000 core cluster in a short amount of time on AWS?
Yeah, we actually did a use case earlier where we were fortunate enough to get a couple of awards on for a 50,000 core molecular dynamics use case being run by a 200-person organization, Schrodinger. So they actually have a team that designs and creates algorithms for measuring docking between a cancer target and potential compounds that might help address the cancer. And what they ended up doing was running about 21 million compounds. That's 10 times as many compounds as they would normally be able to do using a more accurate algorithm, which takes 10 times longer. And in order to do this, we needed a massive amount of compute power. So we ran 12 and a half years of computing in 3 hours. We spun up at time 0, they had no cores. At time hour, they had 51,000 cores. At time 3 hours, they had 0 cores and they were paying nothing anymore. And the total cost of using that 50,000 core infrastructure, which is about $20 million worth of infrastructure, was $4,800 an hour. So that for 15,000 bucks, they had for 3 hours more cores than its top pharma put together. And then they turned it off and we're done.
Yeah. And now to get that opportunity, there was a contest, wasn't there?
Yeah, we actually did that as a separate use case. So
okay.
the 50,000 core use case, which by the way, if we ran it today using spot market prices on AWS, instead of $15,000, the cost would be $3,000. So that would be $20 million of infrastructure to run high performance computing for $3,000 total. 12 and a half years of computing. The large contest we did was actually a big science challenge. So we wanted people to think about how they could take advantage of accessing this massive amount of compute in a very short period of time. And the winner was the Victor Ruwadi, who's a researcher at the Morgridge Institute up in Madison, Wisconsin. And they had a 78 terabyte data set of genomic data around stem cells. They ran basically a pairwise comparison of different samples to create a lookup table so that when researchers are trying to figure out how did this skin cell that I scraped off and turned into a stem cell, how did that differentiate? Did it actually make it to the vascular cell that I wanted it to be? When they do that lookup table, it was a massively compute-intensive problem. So it was about 1 million hours. That's 115 years of computation. So I'm going to coin a new term here. This was a compute century of computation that was done in about a week instead of 115 years. So if you'd actually started a single core in the year that the term computer was first used, meaning an electronic calculator, that was in 1897, and followed it all the way through World War I, the Roaring '20s, the Great Depression, World War II, the 50s, plaid, the 60s, flower power, disco, the 80s, all the way up through Gangnam Style. It would have finished earlier this year, that entire computation, and instead it got done in 1 week for a cost of $19,555.
So a compute century for less than 20K.
Yep.
Amazing. So,
yep.
I was going to ask you, when you can enable this kind of science in a cost-effective way, and things like cancer and stem cell research could blow the doors off, helping people, how does that feel that you're seeing your company enable this kind of thing?
It's very rewarding. I mean, I have type 1 diabetes myself. There's 12.5 million new cancer patients every year. There's about 2 million new diabetes patients every year. And so providing the compute software, the software that makes it possible for people in life sciences, and this gets back to your question of who do we help. We also help people in insurance that run risk analysis on the nation's retirement funds. So this is companies like Pacific Life, et cetera. We help people in manufacturing, so folks that are designing both medical devices but also consumer products to be able to run computational fluid dynamics at scale. So it's a very privileged position to be able to enable people to ask bigger questions, ask the right question, and be able to execute it in a cost-effective and fast way, thanks to cloud computing and thanks to taking advantage of all their internal resources.
And then what do you bring to the table? Is it just the fact you have the software to set this up quickly and efficiently and manage it, or what does Cycle do in the grand scheme of this then?
Yeah, so Cycle's software essentially helps with both the provisioning part, but also monitoring exactly what's going on and all the systems involved with creating clusters of this size, whether it's leveraging multiple internal clusters and routing work between them, or alternately taking advantage of whatever scheduling system you use, whether it's Grid Engine, PBS, Torque, etc., LSF, and just making that scale. Our software essentially helps orchestrate all of that so that you can run a workload on it, but not have to know the details of how to take advantage of things like AWS in your internal VMware environment.
Terrific. Well, hey, thanks.